Good morning, everybody. How y'all doing? Let's get started. Um, yeah. Looks like we've got a good number of people here, right? Just to start things off. Thank you all for showing up. Um, and I'm just making sure everything's up and going and everything looks good. Um, hey, Ole, welcome to the stream, man. Um, so, and Michael and Ole, welcome to the stream. Um, you guys, the two of you, if Henderson shows up, you got to kick his butt today. He should definitely not be attending today for sure. Um, he can rewatch it, right? But today is not a good day for the man to be attending. Um, and I don't want to share too much of his personal life, but we'll leave it at that. Ole reached out to me just before always the plan. Thank you, Michael. Thank you for watching out for him. Poor guy. Um, yeah, we don't want him to be consuming the subversive information that I keep sharing. Um, let's see. Ole reached out to me before the stream, and he's hitting 3 years. Dude, 3 years is amazing. Congratulations, man. Thank you so much for just hanging out with me for 3 years. That means a lot. So, yeah. What are we doing today? Well, today we're gonna dig deeper in. We're gonna try and get rid of all of this stuff, right? Um, I don't know. For whatever reason, I've been the one on the teams that I'm a part of. You thought it was a maximum of 1.5 years. That the crazy thing to me about that is that tells me I've been streaming for over 3 years, which is crazy. Um, because the message you were showing me was talking about what was it? It was Stately and X State, which it's crazy if I haven't been talking about Stately and X State for like a year or two at least, then we definitely need to do something with that. I think I started YouTube in the beginning of 2024. That means I streamed for, I'm going on maybe 5 years. What the heck? Do I need to look at my Twitch channel? You guys, let me just look at my Twitch channel really quick. And see if it gives me any information about how long I've been streaming. Analytics, followers. Just looking to see. I'd have to dig through settings. I don't want to pull us too far off, but that's crazy. Yeah, you did. That was one of the things that actually encouraged me to start doing the multi-streaming and to look at how I can keep stuff on YouTube. One of the things that I need to get better at, and I've been just trying to figure out how to do it, is creating like shorts, because I know there are some things from like the last couple of streams that people would want to see. People tend to reshare some of the drawings and stuff that I do and the discussions like that. So I need to make those easier for people to share, to where you're not trying to share a link in a 3-hour video, but you're just sharing like a 5 or a 10 minute quick little hit. So I'm definitely looking at that. Let's get my extensions restarted while we do this. But today we're looking at this Prisma upgrade. And you guys may have seen before the stream started, as I was working through it, there was a missing file. And I on teams, when I'm on an engineering team, I'm always the person who gets who tends to pick this stuff up, right? Oh, the other thing I was gonna call out is the Warp team reached out to me during the week to let me know that they're working on the bug in Warp, where the sim links have problems. So I am watching the bug that they shared with me. Warp just went open source, which I hope is a good thing. I'm hoping. I really like Warp's AI stuff. The GitHub CLI is pretty good, but I like the way Warp works, the way it's able to grab all sorts of context and stuff. So I'm hoping that I'm able to point it at my own LLM. I've got a couple of other ideas that are cooking. One of the things that I'm thinking about, and this one will probably become more relevant, because in the near future, I think the cost of LLMs is going to go up significantly. It has to. And we're already starting to see moves like this with like GitHub stopping their premium requests and moving into usage pricing. Claude, it's crazy. Over the past 2 months, Claude in Copilot went from a 3x token usage to a 7.5, and then last week we noticed it's a 15x token usage. So it doubled in price already. So we can see a lot of these big LLMs are starting to charge more. They have to, right? They're all operating at a loss, and investors aren't going to be there forever. So I'm thinking through like distilling models, like stuff like that, or even so. First of all, don't take this as an ad. It's not an ad. This is just what I use. There are a lot of good LLM services out there. I've stopped self-hosting quite a bit, and I am now using Featherless to do a lot of my hosting. And Featherless gives us access to like the Quen models. So if we look at the Quen models and we look at popularity, and I'm not sure how easy this is to see, but we've got the Quen 32B, we've got a Quen 32B instruct. This is specifically for a coder model. And this one's a 2.5. This one is the 3.6 model. This model I've heard is really good. This one is distilling DeepSeek and Quen together, which is a fascinating idea. And so you can see that there's a lot of open source models out there. And if we look at my graphics card, my graphics card can't run these models, and I definitely don't think that it would be able to run them at the same time as streaming. Like this model's a 2 billion parameter model. It's a distilled model. So pretty small. You can see that it might be difficult to see, but on Featherless you can see how big the model is, the context, and then what is the base model that it's built on. this one is a 480 billion parameter model. So we're getting pretty close to like Quen, this one being on the level of like OpenAI when it first released, right? This is a pretty big model. There's no way I'd ever be able to run that on my machine. If we look at what I could probably comfortably run, we could run these, we could run this, that, and then I can probably run the 10 to 15 billion parameter models, but I definitely couldn't stream while doing it. So if we look at this, like there's an 8 billion parameter Quen instruct. And so I'm very curious about running these smaller LLMs, right, SLMs, and seeing if like an agentic flow works really, really well. I haven't had a lot of time experimenting with that. And so, with the cost going up, I think it'd be very interesting to take a look at these and see, what we can do with these models. The reason that I run Featherless, and again, not sponsored by them, not an ad, just for people who might have questions. The reason I run Featherless is that for $25 a month, I can run any model on Hugging Face. And the way that Featherless works is it uses a concurrency model. So you can see that like this Quen model here has a concurrency cost of 2. For the price that I pay per month, the concurrency cost, I can run up to 4 concurrency at the same time. So I could run 2 models with a concurrency cost of 2. Like the newest DeepSeek that just released, version 4, has a concurrency cost of 4. And so, there are just different costs on the models out there. And then, so I can run any Hugging Face model. There's a concurrency cost based on how popular it is and stuff like that. How much, how costly it is to them to run it. And that $25 a month equated to almost the same that I was paying in electricity when I worked out like the cost of cooling my house after running my graphics card and stuff like that, right? It was pretty close, right? Like it's still cheaper to run it myself, but I started doing a hosting, and there are a lot of other services out there like this. But if you guys want to get into self-hosting and stuff, unless you've got an amazing budget and amazing graphics cards, I actually find this is better. Just being able to run something in the cloud. The downside is that it's not really local. And so when you're investigating this stuff, definitely take a look at like the privacy and what they do with the queries and stuff like that. And, make a determination if you're good with that privacy policy, right? Because once you're running something on somebody else's servers, they've got control over everything. So just make sure that you're checking that out and you're being careful. Anyway, back to what we're doing. I definitely want to look at stuff like that, and I really want to look at how have open source models come in regards to Angular, especially with something agentic, right? I'm not even sure if I could hook up Quen to. Oh, that's a good question. Let's just use Quen with Google Antigravity. Oh, well, look at that. So it looks like you can use Quen and Antigravity. So with a little bit of research, I should be able to hook it up and show you guys how to do it. And it looks like it's a fairly popular thing to do. So we can take a look at that in the near future. Anyway, let's get back to it, right? And by all means, you guys, feel free to bug me and just ask questions and stuff as we're going through this. But yeah. So Ole, that is a fascinating. Um, that's a fascinating topic. Um, so yeah, Ole's saying that he's seeing news about layoffs due to AI, but I don't understand how it can replace engineers. It can't even fix some spaghetti code bugs. I understand that the issue is in the mix of reactive and template driven forms. Exactly. But how could someone without technical knowledge fix that faster than a developer? And there's some interesting articles out there. There's this article on NVIDIA report LLMs cost more than developers. See if that finds the one I'm looking for. So last week, there was this discussion, and NVIDIA came out and says that AI is still more expensive than actual workers. But companies don't see the extra cost as negative, right? So you've got companies out there saying that they're doing layoffs because the cost saving or whatever, right? But when you look at it, the cost of tokens, and I can share the. I don't want to sign up, um, but um, there are a bunch of different pieces on this, right? Fortune's reporting on it. Yahoo's reporting on it. Even Facebook, right? Like you've got all of these people saying that AI compute costs more than human labor, right? Which is a fascinating thought. Um, and then you have the Ruby. You have Ruby senior developers needed for AI deployments, right? And so you've also got you've got this discussion too, where the creator of Ruby on Rails is saying things like the most successful and applicable agent acceleration I've seen has been from the most senior people, the people who are able to validate whether the agent produces or whether what the agent produces is suitable to be deployed to millions of people, right? Whenever it's mission critical or for something of that nature, we cannot yet rely on agents to have vetted it all, and junior programmers are not capable of figuring it out. And there's some really good information out there about things like that, right? And what we're finding is that agents aren't good replacements for engineers. Agents rely on senior engineers to be at their best, right? It takes a combination of a senior engineer and an agent to really be at their best. But we still see companies that are blaming layoffs on cost cutting and AI. So when you look at those together, it paints a story that it's not AI that's taking jobs. What's going on is you've got companies that are overextended, right? They've hired too much. They built for a bubble. They're beginning to realize that in the current economic crisis, or in climate, not crisis, climate, in the current economic climate, they need to scale back, right? Well, when a company comes out and does mass layoffs, when a company comes out and, gets rid of a large portion of their workforce, it's negative press. It's never good. Nobody's ever happy to see a company take jobs from people, right? And so it's often better to include something that everybody already hates with the news, right? So you could come out and you could say, Jason Corp laid off 20% of, their Jason Corp laid off 20% of the total workforce, equating to 15,000 people, right? And that plays all over the news, and everybody's just like, "Oh, Jason Corp sucks. Jason Corp, don't do anything with Jason Corp. Boycott Jason Corp," right? And like, people are angry. Um, or you can come out and you can say, "Hey, Jason Corp has decided to embrace AI. We've also recognized that returning to the office is the best way to get collaboration, even though AI doesn't collaborate. And we're also trying to right size our company and make strong strategic decisions in this economic climate. And also, the current political administration sucks, and that one works independent of the country that you're in. In light of this, we're having to make a small change to the workforce, right? And then you bury the fact way down in the story that it's 20% of the workforce and 15,000 people. And suddenly everybody's like, AI sucks, it's taking our jobs, right? The economic climate is so hard. The current administration sucks, right? Like, everybody does this all the time. It works regardless of political leaning. It works regardless of country, right? Because you get people arguing about stuff that isn't the fact that Jason Corp just got rid of 15,000 jobs, right? And that's a cynical take on it, but it's also the way business works, right? People are no longer arguing about how evil Jason Corp is. We're instead arguing about, oh, AI sucks, it's taking jobs, AI is going to take your job because it just took my job, right? And everybody's freaked out about AI. The reality is, all of the research and stories out there show that AI is way more expensive. And so if we're going to be embracing AI, it has to take jobs, but we're kind of in a oh, why am I drawing a blank right now? There's a movie about some people who get frozen and then woken in the future. And everything's become so easy in the future that everybody's stupid. So, yeah, I definitely remember the problems with IT jobs started before AI. It was around the end of 2022. Yeah, and the interesting thing is, when the job problems started happening, the blame was on the tariffs, the U.S. tariffs. At least that's the way it was in the U.S. I don't know how it was in like Europe or Asia, or any of the other big markets, Africa. I don't know how it was, but here in the U.S., people were blaming it on the tariffs, and when that didn't work out anymore, then it really shifted to AI, right? Um, and AI works good if your code is okay. The interesting thing about AI, um, and again, a very cynical read on LLMs, because LLMs, I use LLMs all day, every day. I love LLMs. But if we look at LLMs and code gen, they just wind up being almost like an intelligent copy paste, right? LLMs are incredibly good at finding patterns in code bases and adhering to those patterns. Um, and when you work with LLMs work with the context that they've got in memory and all of that stuff, right? And so when you have LLMs generate stuff, it winds up being good copies of other places of your code. If your code is good, that's a good thing, right? When it's got good context to work with, when it's got good instructions, when it's got good guardrails, that's a good thing. Um, but as we know, most companies don't have the funds or the ability to create Google level engineering, right? And so we pretend like we've got Google level engineering when really what we've got is the Timo version of Google engineering. Um, and we don't produce the same quality that's going to give us the best outcomes. And the reason for that is that companies just don't have infinite budget, and they have to make decisions. Um, and it's the same with LLMs. These companies that can't produce top tier engineering are not going to produce top tier LLMs, and they're going to produce more and more slop, right? It's just the way it works. And eventually people will figure things out. Frameworks will be put together. It's the same thing with the web. The days of jQuery, the web was mostly spaghetti code and slop. Slop produced by humans, but it was still a lot of slop, right? And then the frameworks came along and made it better. But people, can still make slop with frameworks. And it's just the way it works. You've got tight deadlines. You've got 2-week delivery schedules. You know, you've got delivery over quality. You've got all these different factors that go into it. And the reality is right now, even the best engineering is telling you can't take the human out of the mix. And man, why can't I think of that? Why can't I think of the movie? I can see the actors. It's because my brain's not focused on that. As soon as the stream ends, I'm going to be able to. I'm going to be able to think of the movie. But the movie really winds up being a bit prophetic, because it talks about the brain drain that happens when things get too easy. And that's my fear right now, is that the current AI trend is making it so that we don't have that treadmill that turns new engineers into juniors, into mid, into senior. And so we're trying to cut out that like junior engineer, right? But we need senior engineers to make sure that everything works. And if we aren't creating new seniors because we don't have juniors and mids to become seniors, then we're creating this brain drain where the people who understand the technology and who are able to deploy the technology are slowly aging out of the system, right? People like me will be retiring, or moving on to management or leadership roles. And what do we replace them with, right? Who will be the people who can go in and look at, an incident, a production incident, and help get things back online because the AI failed? And as that resource becomes more and more limited, right, by the law of economics, that means that resource is going to get more and more expensive, and it's going to get more and more concentrated in places where people can charge for it. And it's not a good place to be, but we'll see what happens. Anyway, yeah, that was I don't think things are dire. Let's put it that way. I think there's enough people out there that are looking at what's happening and positioning themselves to understand what's happening, and positioning themselves to ride out the brain drain, but also to help their organizations survive it. I think there are a lot of people out there that look at the news and go, oh, this company's doing it, we need to do it too. There's a lot of followers. And, you know, we've talked about it a bit in the past, right? Where you have these two extremes, right? And this extreme is, in this case, everything is AI. And in this case, everything is human, right? And then we have the pendulum that swings back and forth between these. Whoops. Oh, no. So we've got the AI, the human, and we've got the pendulum swinging back and forth, right? And I right-clicked, and that made everything go away. So this is our AI here, and this is our little human here, right? And drawing this with a trackball, you guys should be very impressed. And right now, the pendulum is swinging over this way, right? It used to be over here, and now it's swinging over this way. And the problem that we get, and you know, the reality is that the pendulum should probably exist somewhere in this area, swinging back and forth between the two extremes, right? And it's this way with anything that we have two extremes on. But what we get is the pendulum gets, you know, somewhere over here, and it starts to gain momentum going this way, right? And the leaders are pushing the pendulum maybe towards this end, but, right, the companies that understand are pushing maybe towards this end. But what you get is you get all these little companies, right? And they just push and push and push on the pendulum, right? And they keep pushing this way with their small pushes as they follow, right? The followers pile on. And as we know with like physics and stuff, and when you're calculating moments and pendulums, you've got to add up all the force vectors, right? So all these people piling on push the pendulum further than it should go towards AI, right? And then you get the smart people over here, and they're like, no, we should be here, or we should be here, or we should be here, or, right? And they're like, okay, we need to bring the pendulum back. So they start doing stuff, right, that starts producing forces to bring the pendulum back. And then you get all the followers, and it'll probably swing way crazy over here. And then, you know, we're going to get these big oscillations. And eventually, everybody will realize, oh, hey, the thought leaders are trying to keep us in here. So we're going to follow and try to keep the pendulum somewhere in here. But, you know, we're in the Wild West right now, where the pendulum is just going to swing wildly and crazily. And that's the way I look at the world, right? Is there's often two opposing extremes. And you have the thought leaders trying to keep the pendulum in between those two extremes. And then you just have the followers who are like, oh, did you see what this company did? They're so smart. We should do it. And they push hard. And then another company's like, oh, look, two companies are doing it. And then like everybody's like, oh, everybody's doing it. And suddenly the push is just way too hard, when really we needed to keep, you know, the push much smaller. Eventually it stabilizes. You can't have those wild oscillations. It just causes too much disruption in what's going on. But yeah. Man, I got pulled way off topic today. I love it. It's this kind of stuff that I think about on a regular basis, because strategically you need to be thinking about, you know, what happens, right? What happens if? What's the extreme? What's the extreme conclusion of this? And what happens if we reach that extreme conclusion? How do we step back from that, right? What's one step back from extreme? What's two? What's three? What's four steps back from extreme? And that's just the way my brain works. And um, I don't know. when when Michael will replace AI. Michael cannot be replaced by AI. I'll tell you guys that. I've tried to build agents that replace Michael, and Michael still beats them, and he doesn't even know he's trying to be replaced by agents. So I think if he knew, if anybody ever told him that I was doing that, he would kick their butts even worse, right? So I can't tell Michael that I'm trying to replace him by AI, because if I do, he's just going to work harder. Um, oh, he will, yeah. Um, he will replace AI. Yeah, well, that's what I'm saying, is that he's going to eventually replace them, because they can't compete. Um, I there. So you know, probably 3 or 4 years ago, I was saying, AI could never take developer jobs. Blah 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 blah. I was obviously wrong, right? That doesn't play well. Um, in the current climate, AI relies on qualified developers to guide it. I don't know how long that's going to last. Um, but the reality is, a lot of developers are moving out of frameworks, are moving out of writing code, and moving into telling AIs and LLMs how to work. And these big skill files and these big agent files, and these MCPs, they wind up being what code used to be. And so developers aren't going to disappear. There's just a large portion of the population that doesn't have the mental training, and they aren't able to logically think through things. So they can prompt LLMs and get something good enough, but they're never going to get quality that top LLM prompt engineers can. Right. And that's what we're calling LLM engineers or prompt engineers or whatever. Those are really like the cutting edge of developers and programmers at this point in time. I think eventually we're going to just start seeing a lot of hybrids, people who do both very well, and who aren't specialized. Like, we'll see a lot less specialization in front end versus back end, or desktop versus mobile, or who knows what, and a lot more specialization in prompting versus coding and things like that. Is kind of the way I think it will go. And a half building taekwondo. Wow, green and a half. Alex Rickabaugh. What I wonder is, today it's clear AI plus qualified developer is way more cost effective than AI alone. Will that change in the future? And that's an excellent question, Alex. First of all, thanks for showing up, man. I really appreciate you showing up, and that's a very insightful question. And that's where I think the industry will have to go. And at least until we get to like the AGI type stuff, right? Until an AI can come up with something it's never seen, I don't think we'll ever get away from an LLM, an AI, plus a qualified engineer being better than either one by themselves, right? I look at it kind of like, back in the 80s, we used to think about cyborgs and stuff like that. My contention, and this is based largely on a contention that I heard from one of the future thinkers, is that humans have become cyborgs already. And the reason we're cyborgs is because most humans carry a computer around in their pocket, right? And when you're as old as I am, you remember back in the 80s, when you wanted to go anywhere, you got directions, right? Somebody told you, you go to the big tree. At the big tree, you take a right. You look for this gas station. You take a left at the gas station. It's 2 roads in. ours is the house with the blue door or something like that, right? Those were the kinds of instructions you got. Eventually, we started getting things like MapQuest and things like that, and people would print off turn by turn directions, right? Turn left on this road, turn right on this road. Then we started to get like GPSs that would be in cars. And then eventually that GPS technology moved into our phone. But beyond that, we don't remember things. We don't do math the same way we did as when I was a kid. There's a lot of things that we haven't done. And the reason is we carry a second brain around in our pocket, right? And so humans are becoming symbiotic with the tech that we live with. I look at AI through the same lens. We're in a symbiotic relationship with the LLMs, and we're in a symbiotic relationship with, with the organizations that we work for. And when those symbiotic relationships work, they're really, really good, and they produce a much better and much richer organism than they would if we tried to use either one by themselves, right? And sometimes when you take a symbiotic relationship and when you separate it, the two halves die, right? They need each other to survive. I'm looking at AI and LLMs in kind of the similar way, where until an AI can come up with an idea that it has never seen, it's going to need the human. And until the human can keep as much context and be able to look through as much code as fast as an LLM, the human will always need the LLM, right? They're two halves of a much more powerful organism. But that's the way I look at it, Alex. I think that the leaders in the industry, and this is entirely my speculation, right? But the leaders in the industry recognize that, and they're going to be building towards that. They're going to be building towards engineers that can use the tools to produce much better results for a lot less, right? One of the things that I do for work is a bit of AI governance, and part of that is, I see a lot of skills show up because people want to use AI, but are those skills just burning tokens, right? Maybe I write a skill that makes sure that all of my code is properly indented, right? Seems really, really cool. It's able to understand the code and it indents things and it looks really, really cool. It demos really, really well to anybody who's not a developer. Anybody who's a developer is like, hey, why aren't you using prettier, right? Why aren't you using lint rules? And that's where I also think that developers are important, because how do we get those deterministic results? And who is able to look at what we're doing and decide that could be deterministic? That could be a lint rule that we could feed into the LLM to help the LLM see, oh yeah, let's fix this, this, and this, right? And get closer to deterministic, and allow the LLM to do what it does very, very well in pattern matching and pattern recognition and things like that. Yeah. Anyway, we're going to get into this. There's a reason that that I wanted to get into this, and it comes down to Signal Forms introduced standard schema to Angular, and Nest.js library. Is this the one that I was looking at before? Yeah, this is. This library is really cool. Is this the one? No, it's not. It's not. It's this one that's literally right below it, right below my Google search, right below everything else. So I've been looking at this library that allows you to introduce standard schema into Nest.js. And so if we're using a full stack, or if we're using an NX workspace, and we're keeping our Nest and our Angular in the same place, and we've got standard schema in our signal forms, and we've got standard schema in our Nest. And by the way, Nest 12 will be bringing standard schema to it. Then we can start to look at standard schema files as a way to validate front-end code, but also validate back-end code, and we don't have that drift, which is a fascinating idea to me. So I want to take a look at this too, and look at creating standard schema validators that we can share between our front and our back end. So yeah. While Alex is here, we were discussing a great section about how to design signal forms. But how should we design signal forms when we need to preserve all fields, ID, order, etc.? Because it will be very hard to have a function that converts everything back to the domain model. So you're saying you're saying let's go take a look at, where is my Excalidraw? Right here. Oh, this one I should save. Nah, we can redraw it. YOLO it, YOLO it. We're getting rid of it. So what you're saying, Ole, is we've got this form, right? And within the form, we've got an ID, we've got, you know, a name, we've got maybe favorite TV, or not TV, but favorite shows, right? I say TV because I remember when TV came over the air, but now people watch shows on everywhere, right? So TV doesn't really make a lot of sense. But our favorite shows is an array sorted by preference, right? Right? Maybe we've got this form, and you need to save it as is, but also we have an array of ID and names. Oh, so what we've got is within this, you're saying we have something like this. Get out of the way for a bit. Let's group this and let's copy and paste it a few times. Let's bring this back over here. So you're saying that we've got something like this, right? And we can get rid of this one. And this winds up being a foreign key that's stored in an object that has its own ID and its own stuff, and this is nested inside of it. So if you update, you need to save the original ID. If you added new items with no ID, as backend requires the whole model, what we don't need in the form. Right. So the ID itself is not part of the form, but it is an important part of the model, right? And this is where I don't think this is part of the form, right? Because when we talk about it, and we talked about this a little bit before, but we've got the state logic here, right? So we've got form logic, right? That is part of the state machine. Beyond that, we've got our business logic, right? And that's also part of the state machine. We've also got we've got our business. This is our business, and now our server, right? We've got our server logic here, and right, and what we want is we want to be able to drive. What you're saying is we want to be able to drive from form to server, but we also want to be able to drive from server to form, right? And when we try to do something like this, we wind up with a difficult path for the exact reasons that you're talking about, right? Like some of them don't have, and I agree with that, Alex. There's nothing inherently wrong with storing extra fields in the form model. Part of it is when we use the form as a source of truth, and this has been a problem before Angular. This has been a problem back in jQuery and all of those in all of the earlier incarnations of the web, right? What you wound up with in those days is you had your form, right? And inside of your form, you had hidden ID equals 1, 2, 3, right? And you had a bunch of hidden inputs like that, and your form became your source of truth. And that's kind of what we're showing here, right? Where the actual HTML form is trying to communicate with the server and sync back and forth. And what Alex is saying, and what I also argue for, and don't let me speak for you, Alex, correct me if I'm wrong, but the smarter way to go is have an object and have an intermediary, right? And this intermediary is able to handle the syncing, right? And so when we talk about this, what we're looking at is we've got this intermediary that becomes part of the state. And the form only needs to display the stuff that we care about, right? Like ID doesn't need to be there, but the name and the TV shows and maybe addresses and other nested information can be in the form. But the piece that handles it all is the form model here, right? This is our form model. And this is the actual HTML, right? And then we were doing this before in Angular. So when we were doing, two-way binding, it's again a form of this, because what we want to do is we want to abstract the form away from the data, because then we can make decisions, right? That, hey, this one has an ID, so it needs to go back with that ID. This one doesn't have an ID, so it goes to the server. The server creates an ID. The server sends back the ID so we can track that ID. We get stuff like that, right? I've seen a few discussions where I've wondered if that was legit. That would be a good thing to have in the docs. So yes, if we can put the whole domain model into the form and automatically get the value back, maybe it simplifies everything. The right flow for me: 1, design the form model to drive the UI you want to show. Then 2, design load save from the back end on top, rather than let the back end shape the form. And that's, I like that point of view too. When we're discussing a reactive data model here, right? And there's a problem here that is difficult to show, and I deleted the image, right? But forms have certain states, right? So if we talk about a form, right, we've got the blank state. And the blank state really should only be able to move to one of two states, right? It should be able to move to a valid state, and it should be able to move to an invalid state, right? And so when we talk about this, our blank state should be able to move to a valid state, right? Our blank state should be able to move to an invalid state. A valid state should be able to move to a blank state, right? And a valid state should also be able to move to an invalid state. And then an invalid state should be able to move back to a blank state, and an invalid state should be able to move to a valid state. But there's one last end condition, right? And this end condition is a saved state, right? And the only one who should be able to move to a saved state is the valid state, right? And so we've got this state machine, and then there's a couple of other, whoops, let's make that blue again. And like the saved state should be able to move to a valid state when we talk about it, right? And a saved state should also be able to move to a valid state. And the logic to define these state transformations is what we're tending to put in the form model, right? When we try to implement this in the HTML, it becomes very, very difficult to describe this, and you wind up with very, very weird templates and very, very weird forms, right? So we've got these state diagrams that are important to understand. And the interesting thing is that sometimes things like ID and stuff like that is part of a valid state, but we don't want it to show in the form itself. So this whole model here really exists as logic outside and defining outside of the form, and defining these state transitions is where most applications encounter their most difficulty, right? Because communicating the state updates, and the thing is, this is a very, very simple state diagram, right? There could be server reads that change state, right? There could be outside, like maybe you're getting stock quotes, maybe you're getting some sort of outside feed that updates and could potentially change your state. Maybe you're getting click events from the user, maybe, right? Like this is a super simplified state diagram. Your state diagrams are going to be much more complicated, and that's where like the stuff that you're asking about, Ole, becomes very, very difficult. And I agree with Alex that in an ideal situation, you design the form because you want the user experience to be the ultimate, the ultimate experience with everything. you design the reactivity for that form with your models and stuff like that. And then you look at how you save that. And if you don't have control over the server, then a lot of what you can do is you can add in adapters and things like that to make sure, right? Like this model should be the easiest model. It should be the easiest to reason about. The flow from the form model to the form and from the form back to the form model, that should be the easiest to reason about. It should be the easiest for you to bug. It should be the easiest for you to test. From this form model to the server, there might be some complications. You might need to reshape the model to be nested. You might need to reshape, make transformations on certain data types. You may need to do other things like that. There can be more complication here. I have patterns that I enjoy that tend to make this easier to understand. Adapter patterns, pipelines, things like that, that allow you to transform the data, that allow you to reason about the data in steps instead of trying to make giant transforms. And there's also complications here between the form model and the server when you start working in things like latency, or when you start working in things like reliability, and when you start working in something like authorization and authentication, and right there's a whole bunch of complexity in this communication here that makes it very, very undesirable to go this way. And so having abstractions and layers of abstractions allows you to reason more about where you move from, but you want this reactive model to be simple and easy to understand. And hopefully I'm making sense here. The form model needs to be able to represent states that the backend model almost certainly can't. Exactly. For the backend model has a whole bunch of, and here's my governance role coming out right now heavily. I've been working heavily in security and governance lately, that's the funny story and the easy attack against LLMs, right? Is LLMs are failing at security and things like that, but the reality is humans fail at security too. And quite often, the stuff that we laugh about in LLMs is just an LLM amplifying the problem that exists in humans because it's trained on our code, right? The server needs to represent certain things, but you never want the server data to be in a bad state. It can't be. And so in the server, and this is why at the beginning we were talking a bit about using standard schema to be able to validate at the server and the front end. Well, why would we want the same logic server and front end? What we're really trying to get to is the fact that our server needs data that makes sense, right? We can't have invalid data here, because when we look at like systems architecture, right? I'm simplifying server. Server is often, you've got micro service 1, right? And then you've got, microservice 2. And then maybe you have a legacy monolith, right? And then maybe fronting all of this, you've got an aggregator of some sort, right? And so when we talk about this server box, it often refers to something that's much more complicated, right? And how does this fit into form logic? And it doesn't, right? And why would we want our aggregator to be sending HTML validation rules back to our form, right? When we go this route, and so we need this API to be able to communicate with these, but these are also probably backed by their own data stores, right? When we look at this, we've probably got a couple of different data stores. You know, maybe we've got an external service, right? Like the complication here gets incredibly, can get incredibly complex when we compare, you know, and all we want to do is display a form that collects, you know, a name and favorite shows, but we've got this complex backend that's doing all sorts of stuff, and you know, maybe we're streaming data to a dashboard, and we're doing all sorts of complicated things on the back end, and you know, and we've got different types of data buses, and we've got all this stuff going on. And we don't want to represent this. We want to leave the server as a black box, right? We want the form to be a black box, but we also need to control our state transitions in our front end. And this is, I'll be honest with you guys, this one took me a while to get a handle on. And the thing that really helped me was when I started looking at XState. And looking at my forms as a type of state machine, you know, a classic state machine, and you know, what allows me to transition to a valid state. And quite often, this arrow doesn't exist, right? Quite often, you transition from a blank state to an invalid state, and it's really only the invalid state that allows you to get to a valid state. And so you spend a lot of time in this state, and there are only certain transitions that allow you to go valid, that allow you to save, and right. But yeah, we're deep in the theory, and here's the thing. In the past, it used to bug me a little bit, getting lost in the weeds, so to speak, about stuff like this. When we look at modern development, this is the stuff that separates amazing engineers from engineers who. This is the kind. I was going to say from engineers who can be replaced by LLMs, right? There's no real engineer who can be replaced by an LLM, so that's a false statement. Understanding stuff like this is what allows you to progress in the current environment that we're in. It's not that understanding code is bad. It's not that understanding code is going to set you back. Understanding code, understanding frameworks, all of that is still important. You still need to be that partner with your LLM. This takes you one step further because the LLM is often not going to make these decisions. It's not really reasoning, right? When an LLM produces code, it's looking at the next token, right? The next most logical token based on the current state. That's how LLMs work, right? If you're a human and you understand state transitions and you understand segregation and you understand things like that, you can start to guide the LLM. Maybe you create skills that tell it, hey, we want a form model. We want that form model to do X, Y, and Z, and we need that form model to work with the form, and we need that form model to work with this API specification, right, our server. It starts putting together the form model, and then you start introducing formal rules to that model that allow the state transition, right? So the form model can only save if it's in a valid state, becomes a formal rule that you've introduced to the form model. Part of the rules for that formal state, right, that valid state is you need X, Y, and Z fields. And if field A is filled out, then field B needs to have a value. And if field B has a certain value, then field D needs to be checked, right? All of these state transitions that when things happen, transition us from a valid state to an invalid state and back and forth, right? And eventually we arrive at a valid state that's able to be saved. But all of that type of thinking is the type of thinking that makes you a good partner with your LLM. And so, you know, when we talk about what we need to do to be a good engineer, and this advice I would have given you 10 years ago. Well, probably not, because I didn't understand it 10 years ago. But if I understood it 10 years ago, I still would have been giving this advice, even if I knew nothing about LLMs. As an engineer, your progress early on, you need that drive and that passion. You need to be participating in framework wars. You need to be participating in flame wars about tabs versus spaces. You need to be participating in language wars. You need to be, right? And I say that a bit tongue in cheek, but the reality is you need that passion to drive you into a good foundation, right? And when you're passionate about things, that passion will help you move past those points where things become difficult. And you know, the passion and the ability to be able to participate in arguments and things like that helps to train your brain to be to think through things logically. But the other piece of that is, you know, I joke about flame wars. You need to be respectful, have your opinions, be passionate about your opinions, but be respectful of other people's opinions, and be willing to take guidance from others. Be willing to take your opinion and look at it through somebody else's lens, because that's how you're going to learn, and that's how you're going to progress into a much more senior engineer, right? That passion is going to drive you through junior. It's going to drive you through mid. It may even drive you through senior. Once you get into like tech lead and things like that, that's when the craftsman side of writing software becomes less important. And when I talk about the craftsman side, that's like the code, you know, the quality of the code, understanding how to write, you know, good code. You talk about that a lot. It's like junior to senior level. Once you get to senior level, you understand that stuff and you can produce amazing code. Now it's time to start getting into the theory, right? Understanding why diagrams like this make sense or are important. Why something like this that's super simplified can represent something way more complicated, and why it's important to be able to create that story, right? Understanding, you know, the classic design patterns book was really what opened up my eyes to the fact that, you know, software isn't just about me getting on a keyboard and typing code, right? Domain driven design was another book that really pushed me to think outside of, like, you know, classical coding, and to think more about what does that code represent? What does it mean when I put everything together in one giant file versus modularizing things? What is the cost of the abstraction I'm introducing, right? Things like that. And once you move into that area, you start moving into like tech leads, you start moving into like staff engineers, you start moving into architectural roles. Um, and once you get into those roles, and you'll live in that world of theory for a long time, and then you kind of come full circle. You start talking about code again, right? But then you also start talking about code through the context of cost. And you start talking about code through the context of longevity. You start talking about code through, different contexts. But stuff like this is what's going to catapult your career, from what I used to call myself early on was a code monkey. And you could probably still find it on my LinkedIn profile. One of my earliest positions, if I haven't taken it off right now, I called myself a code monkey because you asked for it, I write it. That's the way I looked at life, right? And that's perfectly fine. The problem is code monkeys don't survive well in the current environment. Yeah, definitely. Thank you guys for the comments. The form versus domain concept is going to be the largest paradigm for this whole mentality, and that has been drilled home by that doc page. I'm already using that in reactive forms. And the doc page that we're talking about, for everybody, agent skills, man. I know I've got it here somewhere. You know what? Instead of doing that, let's just go. Oh, no. I just scroll up and just randomly click on one that I wanted to change. But you guys, here's the thing. Some very, very intelligent people put together the discussion on forms with angular signals. And Ole and Michael are totally correct. This discussion about the form model versus domain model is exactly what we've been talking about today, right? And it, I got distracted. I get sniped so easily. So, personal preference. I'm gonna preface this right now. Personal preference. In TypeScript, you can tell a full stack engineer from a front end engineer, by looking at this. And what do I mean by this? A full stack engineer is probably exposed to something like Java, .NET, Rust, right? When they define types, they use interface, right? Interface is a contract. And this is me completely off on a tangent because I look at this code. Somebody who writes TypeScript and has been writing TypeScript for a long time, they got used to the fact that interface was slower than a type because interface can be extended in TypeScript, but types can't. And so whenever I see interface, personal preference, I prefer type, but I know that the person who wrote this has been influenced by another language. And so that's just me off on a tangent. But yeah, the important thing here is to understand what makes a good form model, right? And this is key. This right here is something we've spent time talking about on stream. Because when you don't initialize all fields for a form model, you wind up in, well, let's take this, right? Let's take this and let's go to typescriptlang.org. And let's go to the playground. And so we're gonna take out the signal here. And we're gonna look at these types, right? So const my type equals type of task model. Does that not work? So now when we look at my type, no. We'll just look at it here, right? Title, description, priority, and whatever, right? And if we look at const bad task model, or we'll create type bad task model, right? And we'll turn this into a type here. Type task model equals, and this has to be a string. And this has to be a string, and priority can be medium or high or low, and completed is a Boolean, right? But when we look at a bad task model, and this is for a form model, but I would argue it's the same for everything. If we do title here, and we make it optional, and we say it's a string, right? And then we also say, hey, description is optional, and that's a string. And then priority is optional, and that's a string, right? And no, we'll make it medium, high, or low, right? And then the last one is completed, and that's a Boolean, right? Let's set up prettier. Where are my settings here? I don't know. I won't worry about it too much because but let's take a look at a couple of things that why this is important, right? If we look at const and we look at process task model, or let's say save task model, right? And this takes in a task of type task model. And we'll have it return a Boolean. And I guess because we won't define it this way. We'll just change it to a function, right? And it's going to return a true or false. The other thing we need is a function, and we'll just call this save. And save is going to take a task, and it's going to take the shape of this task is going to be an ID, which can be a string or null. And we're just going to steal the task model here, right? And it is going to return a Boolean, and we're going to return true, right? This is just demo here, right? So our save task model, we're going to return, and we're going to return save, and we're going to return task, right? Well, task model is not assignable to ID string or null because ID is missing, right? And so what we can do is we can just say, hey, let's fix that. We're going to say ID is null, and then we're going to spread our task across it, right? And that works just fine. And we've got a valid object that we can save as a task, and everything's good. But when we go and we try to save a bad task model, and this is our task and our bad task model, and this is going to be a Boolean, right? And we're just going to take this same code here, and oh no, it doesn't work. Well, why doesn't it work? Well, it's not assignable to parameter of this because title, string, description, priority. It's not assignable to this because string or undefined is not assignable to. Oh, right. Oh yeah, title can be null, right? So now if title is a nullish one, and it needs to be task.title, right? Is nullish, then we return false, right? Great. Oh, yeah, a description, right? So then if task.description equals null, then we return false. Right, and oh, we still haven't narrowed enough, right? Because we can look here, title. Oh, properties of title are still incompatible. Type undefined is not assignable to type string. Well, except task. Well, and see, we get into this weird situation where we're having to validate stuff, and it becomes a problem. And this problem, once you start introducing nulls and things like that into the code, it becomes more and more of an issue. And the biggest issue here is that even though I'm checking task description here, it's not really working because even if we go if task dot priority equals null, return false. The problem is that even here, task hasn't been narrowed, right? We're still a bad task model. And so we get into this place where it becomes difficult to validate, right, our task. And this is the problem when we get into forms, is that once you start introducing optional, right, nullish values or optionally undefined values, things like that, you have to start doing checks everywhere. And so when we get into the form, the reason this is better than this is that we aren't having to do checks for title, description, priority, and completed. And that simplifies the logic from the form model to the form, because we know that title can't be undefined or null. We know that description can't be undefined or null, so we can reason about them. We don't have optional fields. In this case, these could be undefined or null, and that leads to issues in the library that's going to be binding the signal to the form inputs, right? Because how do we know that description is supposed to exist when we do that binding and it's just not missing or it's undefined or there's a whole bunch of issues that come about. And so designing those forms properly is important. Keeping the model focused, right? This is an interesting one. man, we should dig into this a lot more too. But yeah, the when we look at, and this is why I like signal forms and stuff like that. Um, when we look at this box here, this box is super simplified in the same way that the server is super simplified, right? And this form is super simplified too. This form can change, right? If this form is an email form, or this form represents this data, there's no reason to present a view to this form that does anything outside of this data. And we can do stuff like that through selectors, right? And when we talk about selectors, we're talking about ways to select smaller pieces of data from a larger set. And this is where things like signal forms, right? One of our favorite libraries to work with here, the NGRX signal forms, comes into play, because signal forms gives us a way to maintain this state, but we can use selectors and compute it, right? We could select only the name and favorite shows and pass them to the form and allow that to bind to the form, right? And then we bind back. So we can select pieces of state, bind them to the form, and then recombine those pieces of state, which allows our form to be very, very focused. One of the worst things about a form is, let's say our state machine has all sorts of rules, and one of the rules in the form, or we change something in the form that could potentially change these rules, but we're marking the form as invalid, but there's no way for the user to make that change, right? That's one of the big things that we're looking at here. Is, let's say that there's a way for the form to become invalid, but the inputs to the form don't allow the user to fix that invalid state. And I've written forms like that, and it's an embarrassing thing to say. I've run into forms like that on the web where data from the server puts my form in a bad state. There's no way for me to change that using the form. The form, records this, the form state is invalid. I click the save button and nothing happens. And the only reason I know what's going on is because I'm used to debugging web applications. I pop open the console and I see in the console, the form is invalid, or something like that, right? Or I debug and I'm like, oh, well, wait, why is this invalid? It's not allowing it to save, right? That's the point of keeping your models focused and cohesive, right? Always consider your validation requirements and what that means. Very important piece. But there's so much here. And man, I got way off topic today. The goal for today was to get Prisma upgraded. But you guys asked some amazing questions. And I missed a bunch of chat. I just missed one. Ole, currently I have 3 levels of nested arrays that I need to submit back to the backend in exactly the same shape. And this conversation, or this conversion, looks very complex. That's interesting. A nested array nested 3 levels deep. There's an interesting discussion to be had here, Ola, because, well, let's talk about it for a little bit, right? And correct me where I get wrong here, Ola, but so what you're saying is we have a container, right? And within that container, we've got another set of arrays, right? And within those arrays, we've got another set of arrays. And so you're trying to present and we can CRUD each of this. Okay. So yeah, so you've got this object, and this object has a property that has another object that is an array, right? That can be represented by these blue boxes. And within that array, you've got these green boxes that represent another array of objects, right? And you're trying to present to the user a way to edit these and then transfer them back to the server. Is that the way? Yep. Oh. So is it a recursive relationship? But yeah, I see what you're saying. And there's a couple of interesting things when you talk about this, right? Because how do you model this relationship for the user to be able to edit it easily? Quite often, you'll see complicated UIs that will add a little plus button here, right? That allow so you'll have a plus button here, and then you'll also have a plus button here. Right. I don't know if this is how yours works, but this is a common paradigm I've seen. So you've got the outer container that allows you to add the inner container, and the inner container allows you to add some more of your some other data to it, right? And so you're hitting pluses, or maybe you've got an empty one at the bottom that when you fill that out, that becomes, who knows what. But this becomes problematic, right? Because you've got the outer object, and this object, to your point, Ole, has an ID maybe. This object is entirely new with no ID. This object, maybe it existed, this one's new, and these both are entirely new. And so you wind up with this big nested object. And you wind up struggling. You know what? Let's just move this up. So I keep searching for it. So let's put it by where we want it. Right, and this winds up kind of going against this rule of keeping your models focused, right? Because it feels like this all fits together, right? This all feels like it fits together because that's the way we've modeled the domain. That's the way we've modeled the object, right? From a user's point of view, it may fit together, it may not, right? Like, a common example of this is we could talk about if we wanted to model this out. This white model here could be a school, right? So this is a school, right? Um, and within the school, the blue could wind up being classes, right? Um, so we'll model out the hierarchy this way, right? So our school goes to a class, and within the classes, we've got students, right? Um, so I don't know what yours, like what your domain model is modeling, Ole, but this is a good way to visualize this, right? So this outer side is is a school of some sort, right? And this school can have multiple classes, and within the classes you can have multiple students. There are other properties obviously that exist here, right? Because the school could have an address, it could have a principal, it could have um, you know um, grade levels. It could have all sorts of stuff like that, right? But then within the school, you've got classes, right? You've got, very, very American centric, right? So you've got kindergarten classes, you've got first grade classes, second grade classes, third grade classes, right? And you could have multiple kindergartens and stuff like that. So you would have multiple classes in a school, and then within each class, you would have students, right? And so you're trying to model um, uh, something bigger than that. But let's back up just a little bit and take a look at what we're trying to do. Um, you're trying to create an interface that allows somebody to edit this entire tree, and that's creating issues, right? The real, if we step back and we take a look at what's going on here, um, when you're looking at a school, you want to edit the stuff about the school. Maybe you want to change the principal or the vice principal's name. Maybe you want to um, maybe you want to update the capacity of the school. Maybe, right? Like that kind of stuff makes sense at the school level. As soon as you get down into the classes level, um, you aren't really wanting to edit all classes at a time, right? You may want to edit an individual class, or you may want to add new classes, right? But when you add a new class or when you edit a new class, you don't really care about the school and you don't really care about the students. And it goes the same, right? When you're in a class's view and you want to start editing students, um, you're either going to want to add a student and enter information about that student, or you're going to want to edit an individual student. Maybe you're updating grades or who knows what, right? Um, but when you're adding or editing a student, you already know the class, you already know the school, you really aren't updating this information. And so my argument here, Ole, is that the user experience model is being driven by this model and not so much by what a user would actually want to do. If you keep the display model grouped like this, but your edit models and your APIs match what you would want to do here, right? You would have, when you edit the school, right, your API is going to have an update school method, right? And methods that allow you to update the school. When you want to edit a class, you go into an edit mode and you'll have an update class API method. When you want to add a new class, then you have a method that is add class, right? But you're staying very, very focused on this level. And it's the same with students, right? Add student, update student, remove student. Same here, right? You'd have remove classes and stuff like that. And so your display model matches exactly what you've shown me, because it makes sense that an administrator would want to look at the entire school and want to look at the classes and maybe even information about the students and stuff like that, right? That makes sense. But once you get into what we're talking about with form models, you want to stay focused, right? So your form model is focused on the school, and your API models then match the fact that you're focused on the school, update school, stuff like that, right? As soon as you start working on classes by clicking the plus button or clicking a class to edit, you've shifted. Your domain is very focused on the class. You don't care so much about the students or the school. You could display information about students in school, but your classes themselves, you're only editing information about the class. So your API becomes very focused on add class, remove class, update class, right? Same with students. And that's the important piece to understand here, that when we talk about things like this, we're simplifying things quite a bit. Everything we're representing here in the businesses and the form models could actually be way more complicated, very similar to the way the backend can have aggregators and microservices here, right? Classes could be modeled in such a way that there's aggregators. Schools could be modeled as, there's different ways to model this. And when a class updates, we could get information back in this format, right? From the, there could be some sort of event that either we fetch the new data or we do different things based on that. But trying to maintain this model becomes very, very difficult, because if I'm adding a class, why do I need to run school validation? Why do I need to run student validation? Why do I need to, right? It's the same with students. If I'm adding a student, why do I need to run class validation? Why do I need to run school validation? Why do I need to worry about the shape of this model? Why not let the APIs allow me to focus on just a student, and then have the display have this shape, right? Does that make sense, Ola? And for anybody else, please feel free to ask questions and stuff. But this is the stuff that when we talk about state management and state transitions and things like that, we could even be talking about the transitions here from a school state where we're editing schools, to a classes state where we're editing classes, to a student state where we're editing students. And the rules for these transitions and the possible transitions that we can make from classes, right? Add class, remove class, save class, those are possible transitions, right? Invalid class, valid class, all of that stuff are valid transitions here. Students has similar transitions off the side, but school can't transition to add class, well, maybe add class, right, and remove class, but it can't transition to invalid class or valid class, right? To do that, it needs to transition to a class, and then the class can transition to invalid or valid, and save class, right? School can't really transition to save class. and things like that. That makes and that allows you to take a very complicated model, right? And the model itself is not wrong. This is the model that people want to see, right? And I chose school because it's very very easy to represent this hierarchy, but we see this all over the place, right? We would see it with parking lots and vehicles, or this is not an uncommon model to see, but and this view is important, right? As a teacher, and there's other things to consider here, right? Like as an administrator, as a principal, I may want to see the school and the classes, and then maybe an average grade across that class, right? So that I can help my teachers do better. As a teacher, I may want to see basic information about the school. I probably should only see information about my class, but I want more details into the grades and the students, right? And so by understanding these state transitions, it also allows us to think more deeply about roles and what views roles should get within a hierarchy like this. And so um, that's where your value comes in, because an LLM could brute force its way through a form that does exactly what you were asking about. But at some point, only the LLM will be able to maintain that form, because no human is going to want to go through the hell that is understanding how the form bindings work, how the data model works, how the right, how the validation model works. It's just a mess. Especially when you start, right, like what if a change is made and suddenly students are invalid, but I'm a principal and I need to go in because we misspelled something in the address and I need to get something fixed really quickly. And I go in and I try and change the school, but because the students are invalid, I can't change the name of the school. And now I'm very, very frustrated, right? Or vice versa. As a teacher who has no power to change something about the school, I'm trying to run school validations over stuff I have no power to change. But I really need to get my grades in for my students before parent-teacher conferences. And now I'm stuck, frustrated because that doesn't work. And it really comes down to a complicated model. Yeah, that's the importance of us as engineers, right? The LLM helps us understand the code, helps us even write the code. But what the LLM can't do is reason about, well, maybe it can, right? Some of the reasoning models have gotten really, really good. But as a human, we can recognize this hierarchy really, really well. And the other thing that an LLM can't do is maybe it can recognize that this should happen, but it can't negotiate with the API team and say, hey, instead of trying to save an entire school object when I make a change to a student, can I get an API that just allows me to update a student? Or instead of trying to save the entire school object and student objects, when I update a class, can I get an API? Or when I remove a class, can I get an API that allows me to just remove the class, right? And it becomes a much easier way to think about, maintain, test, because yeah, you're in a very, very difficult situation trying to maintain all of this, trying to allow the edit of all of this. And let's be honest, it becomes difficult for the people using it. And you get into weird places where, like, hitting a plus here needs to scroll the screen down because you're adding a new object. And oh yeah, I forgot I needed to edit this. And oh wait, where do I hit the save button? And it just becomes way more difficult. Yeah, I think I'm very verbose, but hopefully that helps. here's the other side of that coin, right? Is as an engineer, and as a more senior engineer, you need to get good at telling this story, right? Telling the story of the hierarchy. And you need to get good at influencing others to see this hierarchy and then see your view for how this hierarchy could work. Um, because it's entirely possible that the API team's like, yeah, we aren't going to do that. There's no benefit for us as an API team to do that. You can just give us the entire model, right? Um, and then it becomes a bit of a political struggle, and you may or may not win that struggle. So, what do we do in the case where the API team says, yeah, we're not going to do what you said to do? Well, in that case, our form models still stay very, very tied to the domains, right? To the school, the class, and the students. Um, but our business logic now needs to start implementing things like aggregators, and adapters and things like that. So you can edit a student, and then that student can be updated in the model itself, right? Um, and when you need to go to the server, your aggregator can put the school together with the classes and the students and send it in a way that the server wants. When the server sends its response, then you decompose it into the models that you need, and then you work with those models. But you want to keep this as simple as possible because it helps your humans who are going to be interacting with your application, but it also helps the testability and stuff here, right? So even if you can't get the APIs to do that, you can still build like an adapter layer that sits between the service and your business logic that allows you to create the API that you want. Um, and the name for this pattern is actually the strangler fig pattern, because you're building something that looks like what you want to work with. And maybe in the future you get an API team who's more receptive, or maybe the reason they're not receptive right now is they just don't have the time. And so in the future, when they have the time, you're able to get them to follow through with that. You've already built out your API through an adapter layer. You update your adapter layer to communicate with the new changes, and eventually you take out that adapter layer as the adapter layer becomes unnecessary because the server has morphed to fit the adapter layer, right? You build that strangler that allows you to create what you want, and then eventually the server gets there, and who knows how far out that is. But that's a very powerful way to work with servers you don't control, teams who are um, teams who are unresponsive or don't want to work with you, things like that. Building those adapters, and those decomposition layers that allow you to move back and forth from the domain model you want to use to the domain model you're forced to use. And so this is where your influence and your ability to tell the story will allow you to influence the engineering at the level that you can to try and push towards something more sane, where you've got individual domain models and individual APIs for those domains. And yeah, that's the other piece of it, right? That other piece of understanding how do we navigate to get here from here. Um, and hopefully that helps. And anybody else who's got questions or comments, I'd love to hear them. But this is um, understanding the need to decompose into domains and understanding the need for adapters and decomposition is something that's taken me a long time to learn. And so if I can help somebody short circuit the amount of time it took me to get here, I would love to do it because, man, I have written some crappy code and some crappy UIs that I am not proud of because I didn't understand the necessity of keeping things simple and focused. And I really appreciate the Angular team talking about focusing your models, um, because if you don't focus your models, you can wind up in a very, very difficult situation. Um, this is a lot like my work days. I intend to write code, and then people ask questions, and I never get to the code. Um, no, I'm glad we got through what we got through. I'm working on scheduling my life in a way that I can add a Wednesday stream. I want to add a midweek stream. Um, I don't know when it's going to happen, but it will happen. When it happens, the midweek streams are going to be focused on just the housekeeping stuff that we need to do. So, can I please teach you a basic Python command, dude? I don't know Python. Um, if I was going to learn Python, I would um, I would be asking my LLM. Like if I was going to do Python, I would just go to whatever LLM I'm doing, and I would be like, um, show me hello world in Python. Like I don't know Python. Like if you want to know TypeScript, if you want to know JavaScript, um, so I mean there's a simple Python command, um, um, but that like that's the amazing thing about the world we're in right now is it free? It is free. Um, so GitHub Copilot. So the command that I just ran there is free. Um, the other thing is I use Antigravity from Google. It's free. And in fact, the Claude Sonnet model I'm using right now in Antigravity, I'm not paying for. So you'll get a certain amount free. Once you get past that certain amount that's free, you will have to pay for a model. But um, there are, I don't know what your setup is like at home, but early on in the um, in the stream, we talked about Hugging Face. And if we look at Hugging Face is basically where any LLM that isn't like one of the big, any open source LLM will be on Hugging Face. And if you go to Hugging Face and you search for Quen, Quen is one of the most popular open source models. So you probably, like, this is a 36 billion parameter model, which means that you're going to need probably about 36 gigs of RAM to run this model, which you can do with certain setups. I'm not going to go into setups on how to run this because it would kill my machine. Will it be fine for students? Oh yeah, Quen would be perfectly fine for students. If you want to run it free, I would find a smaller version of Quen. So like if you go here and you look at the trending models, you can see DeepSeek just came out. So, but there's no way you're going to be able to run an 862 billion parameter model. So what you can do is you can come over here on Hugging Face and you can say, hey, my graphics card only allows me to support up to 12 billion parameter models. And you can see here, oh, hey, here's a 2 billion version of Quen. Maybe I could run that locally. Gemma 4 is pretty good. That's the Gemini open source version from Google. Be very, very careful on the ones you pick up. So like this Gemma 4 IT is a thinking model. So this will do the reasoning. So if you want to do reasoning, look at this. Be careful of things like crack and things like that. You don't know what's in them. But yeah, as you look through these models and learn how to run them locally, I would say probably between 12 and 24 billion parameters are something that a student could reasonably run on a machine. I don't know if I would get into that too deeply. The other thing to take a look at is maybe your school gives AI credits. Maybe maybe GitHub will give you a student credit or things like that. Should we also try something like mutative for deep nested models like that? So, man, Ole, hey, no problem, man. I'm happy to help anybody who comes. Just, I'm happy to share knowledge. Like my knowledge and the stuff that I can share is really related to like Java, .NET, and front end, especially like Angular and TypeScript, stuff like that. Angular and TypeScript is probably where I'm the best. But yeah, I'm happy to help just lead people to stuff that I discover in my day to day. So what do you think? Should we try something like mutative for deep nested models like that? So first of all, you guys know I love mutative. Mutative would probably help you be safe in keeping the structure, right? So mutative would help you keep the school containing classes containing students because you can't, like the structure becomes immutable. But what mutative isn't going to help with is the complexity of the structure and the complexity of what you're trying to do. In the adapter layer that we talked about before, and in the adapter layer, I think mutative would be a huge help. And maybe even just maintaining the form models. But I don't think mutative is going to help with the problem you've got. It will help with other issues that everybody has. I think you should be using immutable data in the UI. And I part of that is that the side effects that come from mutations are difficult for UI libraries to reason about. So something like mutative helping you maintain an immutable state makes it so that your library, Angular, React, whatever, right? But Angular in particular, having immutable data with Angular makes your change detection cycles so much more predictable and so much better. But I don't think it's going to really help with the fact that your models are deeply nested. Deeply nested models benefit better from domain modeling, like we're talking about here, and less from man. You're hitting me in all of my greatest hits for the past little bit. When we talk about engineering, right? We've got this Venn diagram, right? And technical solutions, right? And then the other part of the Venn diagram are cultural solutions, right? So here we have our cultural solutions, right? And as engineers, we're incredibly good at these solutions. We're not so good at these solutions, and that didn't do any good. So we're gonna undo that. Right there are also solutions that kind of sit in the middle, and I think the discussion we're having here fits in the overlap between technical and cultural solutions. And the reason I think that is there is a technical solution to this, right? The decomposition into domains is the technical side of this solution. But the reason that you're looking at stuff like mutative, the reason that you're looking for technical solutions is that the cultural solution is difficult, right? And that's where I think as engineers, we want to live over here because it makes sense to us and it's easy for us, right? It's easy for me to drop into code and write a linting rule. It's easy for me to drop into code and code up a solution. It's much more difficult for me to get another team to agree, yeah, this decomposition makes sense. And yeah, I need to do work so you can use a decomposed model like this, right? And that's where we get into kind of this uncomfortable area where a technical solution exists, which is a cost, and a cultural solution exists, which is potentially a bigger cost. And how do we get these two solutions to play nicely with one another? And man, if you figure that out, I would love I'm trying to place the diagram and getting distracted. But if you figure out how to make this piece easier, I would love to hear insights because it's this piece, the intersection of cultural and technical, where things become difficult, right? Most engineers don't live in the cultural side of things. This is typically HR or leadership or things like that, right? Most engineers live in the technical side. A few engineers live in this space here, right? And most leaders don't live in the technical side. And if you don't believe that, right, go ask your leader about AI and see how much you agree with their technical solution or technical assessment of AI. Most leaders, when they assess AI, are looking at it from a business and cultural standpoint. And so the leaders and the engineers that can live in this space and get things done in this space are the ones who are most successful and who are going to be able to write better software because the decomposition is important here. It's the piece of the solution that makes this structure work the best, right? And you can come up with other technical solutions, and you may come up with a good enough technical solution, but it's never going to be as good as when you get, when you get the culture to change, when you realize that, sorry about that, when you realize that sometimes the way the data is stored is not the way the data should be used and not the way that our users want to interact with the data. Does that make sense to you, Ola? All right. I need to end. Thank you, everybody, for showing up. And thank you, everybody, for the questions. All is complicated. Exactly. the right answer to every question, and this is the best piece of advice that I could give you. The right answer to every question you're ever asked, if you want to become an architect, is it depends. As soon as you just start saying it depends to every question you're asked, people are going to promote you to architect. Thank you guys for being here. I appreciate everybody being here. Michael, I've been looking over those PRs that you sent me. Thank you for sending me those. And I'm looking forward to next week. Alex, thank you for being here, man. I really appreciate it. I promise if you attend another stream in the future, we'll write some Angular. I promise, man. That's one thing that I think I'm okay at. I think I'm okay at writing Angular. I'm really, really good at getting sniped and talking about random stuff, but I think I'm okay at writing Angular. So thank you for being here. I really appreciate it. It means a lot that you guys come out and support me. And I really appreciate it. You guys and everybody here. It means a lot that all of you are here. I got sniped again. But anyway, I'll tell a quick story and then I'll end. I was talking to somebody about what it's like to start streaming. Yeah, exactly, Alex. I totally agree with you. Design is the difficult part. Once you've got the design down, the code is much. And the crazy thing is that once you've got the design down and you can articulate that to an LLM, even an LLM can follow your design. But getting that design to a place where it's easy is difficult. But yeah, for just so you guys know, I really appreciate you all being here. I really appreciate all of the questions and all of the interaction. I was talking to somebody who we were talking about what it's like to stream. They're thinking about starting streaming, and the biggest piece of advice I have for anybody who's beginning to stream is, one, be consistent. If you can only do Sundays, right? But make sure you always do the same time on Sunday. Or if you can only do Mondays, but make sure you do, right? That's the important piece about being consistent. The second piece of advice when streaming is you're an entertainer and make things entertaining, but recognize that you're probably going to be talking to yourself for like 6 to 8 months, right? And that's difficult. So if you guys, I don't even know if I have like some of my older streams, but how excited I got when a single person showed up is the same way that I get right now when I turn on the stream and a single person shows up. It means the world to me that you guys come out and you spend time with me, and I thank you, everybody, and thank you for the questions, and even questions about Python that aren't really in my wheelhouse. Thank you for asking them. It means a lot that you guys come out and you share. So thank you guys. We're gonna end here. We'll see you guys next Sunday. I'm not going to promise a midweek stream. I've promised that 2 weeks in a row and completely failed. That tells me that I'm not ready to do midweek streams yet. There have been various reasons why I haven't. I need to be able to get that consistency. But I'm working on it. There will be midweek streams. When it happens, I'll announce it, and we'll start streaming on Sundays and Wednesdays. I need to reorganize a bit of my life and get some different things in place, and then it's going to happen. I want to stream a little bit more. So, but we'll talk to you guys later. You guys have a great week.